Okay guys, so today, let me move myself here first off, out of the way. So today I'm going to teach you guys how to read the activation energy charts. I know we talked about this last week. We did a few examples last week as well. But today what we're going to do is we're going to have an assignment on these. So I want to make sure you guys thoroughly understand how to read them and interpret them. Okay. So we have our activation energy graph right here. I enlarged as much as I could while trying to keep everything else on the screen for you guys. So let's go through everything. So energy of the reactants. Well, the reactants are going to be over here in this area. It's where we start, where our graph starts at. So pretty much all we're going to do is look at that first point, and it's between 40 and 60. So our energy of our reactants is going to be 50. All right. Our energy of our products is going to be our last point on here. Now be careful with this, guys, because I know it's very, very close to this number here. You always want to read these from our y-axis. In other words, you always want to read them with these numbers right here that I circled extremely well. But we always want to read the y-axis numbers because it's always asking for energy. Energy is on our y-axis. Time is on our x-axis. Okay? So energy of our products, here is our point about right there. And we're estimating, guys, if we follow this over, it's about 20. It might be a little over that 20 line, but it's close to 20. So we will call it 20. Okay? Our next one, activation energy of the blue line. If you remember how we calculate activation energy, it is going to be our peak. It's our peak minus the energy of our reactants, okay? So let's do the blue line first. We're right here. So activation energy of the blue line, what's that number? We could say it's like 85, I guess, somewhere around there. All right, 85, we'll go with it. Minus our energy of the reactants, which we already found was 50. So our activation energy of the blue line, 85 minus 50, is going to be 35. Okay. If we do the red line, the reactants are still going to be the same. So we're still going to subtract 50 from it. But this one, here's our point. I'm just going to round it, guys, and say it's 120. It's close enough to 120. And our activation energy for the red line is going to be 70. All right. Next one, which line has an enzyme? Here's how you tell this, guys. Whatever line, it has a smaller peak to it. So if you look here, we have the blue line that doesn't go so high and the red line that goes real high. Whatever one is a smaller hill, that one has the enzyme. So for this one, it would be the blue line. Okay. And then lastly, is it exothermic or is it endothermic? Okay. Go from your reactants. And we're going to go to the products. If the products are below, okay, so products below reactants, like they are here, it is exothermic. Exothermic. So in other words, if we drew a line from our reactants to our products, you see how the line goes down like that? That means it's exo. Okay? So this last one's going to be exothermic. Okay. So there you go, guys. That's everything we need to do there. I think the only real tricky one is determining if it's endothermic or exothermic. All right, and you have your little cheat sheet here. You could watch this video again while you're completing the assignment. Just know if the products are lower or below the reactants, okay, so we have reactants at 50, products at 20, that's exo. Or if you drew a line, the line goes down. There you go. All right. Let's do one more example here. Okay, so this one, a little bit of a different graph, same colors, same concept, okay? Just a little different format here. So we have 0 to 10, 10 to 20, okay, you guys can see, so 5 would be somewhat in the middle. Right? Energy of our reactants, where we're starting at, maybe 3, maybe 4, somewhere around there. We'll just say 4 for our reactants. Our products, again, guys, make sure you're not going down with it. We want to go across to these numbers. So that's going to be about 24. Okay, 25 would be right in the middle. So it's a little bit below that, 24. Okay. Activation energy of the blue line. So we know our reactants, that's going to be 4. Okay, and remember how to figure out our activation energy. Okay, activation energy, I'm just going to abbreviate it AE, is our peak minus our reactants. Okay, so the blue line, we know the reactants are going to be 4, and that'll be the same for the red line. Let's look at our peak. Well, it's up over 50. Okay, it's really close to 55, maybe not quite. I'm just going to say it's 54. So 54 minus 50, or I'm sorry, 54 minus 4 is going to be 50 for our blue line. For our red line, we're still going to have that same reactant number of 4. Let's look where the blue line gets up to, or our red line gets up to, sorry. So it's about right here going across. So, maybe like 38 for guesstimating. That's about 34. Okay. Which one has the enzyme? So again, guys, this is the one that's going to have the smaller hill, the smaller peak. Right? In this one, the red one does not go as high. So the red one is going to have the enzyme. And lastly, is it endothermic or exothermic? Well, last time the reactants were above the products. This one, products are above reactants. And when that happens, it is endo. Okay. Another way to do it, guys, if you draw a line starting from your reactants, go into your products over here. Sorry, not the straightest line in the world, but it's going to go up. If it's up, it's endo. So this one would be endothermic. Okay. So that's it for today, guys. If you are having trouble with this, please attend the live session. Myself and Miss Smiley, we can help you out, especially with the worksheet. You know, we could do it together if you guys want to. So that's pretty much it. Again, guys, you know, if you're having trouble, join the live session. All right. Have a good day.